right, there it is. Well, welcome again, everyone. Well, today's joint webinar is presented by INCOSE Transportation Working Group, Infrastructure Working Group, UK's Rail Interest Group, and also the APTA Systems Engineering Subcommittee. And here's the topic. And our presenter, Oliver, well, he is a passionate systems engineering practitioner, technical fellow, project manager, and the U.S. Global Technical Excellence Sector and Practice Lead on systems engineering, communications, and control systems for WSP USA. So he is a PMP and systems engineering professional, also a certified Scrum Master. So he has over 20 years of extensive international and domestic experience in software and systems engineering across industry. So his expertise in SE and also integration and testing roles on the large systems of system for transportation and infrastructure. Right, and Oliver, I'll turn my share to you. Let me stop sharing and you can begin sharing.
Okay, can you hear me?
Yep, loud and clear.
Okay, then let's share the screen. So what I'm going to do for 1 second or so, show my face. Can you see me? But I don't want you to be distracted. So I just want to be able to put a face to the name. So I'm going to switch it off again.
You look good, Oliver.
Always.
Yes.
Hey, thank you for the invitation. And as you can see, this is actually a presentation that I gave at the International Symposium in this summer in July. And it would have been in Hawaii, right, in Honolulu, had it not been for COVID. So we're looking forward to 2023, right, everybody? Anyway, so as you just heard, my passion is really the application of systems engineering. And it can be sometimes become quite frustrating if you say, hey, there's, better ways of doing this. Wouldn't it be possible, right? And I'm sure a number of people on the audience side have already seen the situation where you basically just show them the doors and saying, yeah, we know what we're doing is we don't need what you're selling us here. And so this time, I was trying to use a different angle, more from a risk management perspective and liability perspective. And then also how systems engineering can be basically seen as that mitigation strategy. So let me move on. So what I want to talk about, and I don't know, somehow my screen is still showing up here. Anyway, let me just go ahead. So on the agenda, so what I want to talk about is first the problem statement and the offered solution. And as I just talked about, talk a little bit about project risk and liability. And systems engineering as basically the liability protection and risk mitigation strategy. Then I'm going to talk about, it gives a little bit of background introduction of the background of the industry and also the project I'm talking about. And as you can see, it's organized or presented as a case study by first talking about the challenges we faced, and then what we were trying to accomplish, and then what we did, and then the results, so to speak, right? The summary, achieved outcomes, and conclusion. And so what I want to start out with is basically the problem statement and talking about, let's see, anyway, the Zoom button is right in front of my screen. It doesn't disappear. Anyway, I think I just have to manage. So what I want to talk about is the problem statement. The first thing is really use an example, right? And so in this case, I'm using the Big Dig project. And it's basically the Central Artery Tunnel Mega Project in Boston, commonly known as the Big Dig project. And basically what happened is it was designed to build between 82 and 2007. So it's always good to use something in the past, right? And so basically what it did is it rerouted the interstate I-93 from going through the heart through the city into a tunnel. And there were actually several tunnels involved. And at the time being, it was the most expensive highway project in the US. And in 2020 dollars, it would have been over $20 billion. And it actually had a number of issues, right? Like thousands of water leaks, design flaws, charges of poor execution, use of substandard materials, and other issues. And unfortunately, what happened then is it led to the death of one motorist and criminal arrests when a 24-ton concrete ceiling panel collapsed into a car. So this is exactly what you see on the right. So I'm providing a couple of also sources, links if you want to read more about it. Basically what happened is the companies that managed the project, and full disclosure, one of the predecessors of WSP was actually involved, had to pay over $400 million in restitution. And then other companies, smaller companies, still had to pay over $50 million. And basically what was determined, the settlement agreement was determined that there was basis for liability. And specifically, what was stated is there was construction management oversight failures in the areas of the use of non-specified materials, of substandard materials, as well as ignored observations stemming from load tests, or failing epoxy mold tests. And all of those issues, what I just listed, but all of those are typically addressed in so-called construction specifications, describing in detail the scope of work, materials, installation, and quality of workmanship. And so while I'm using the word construction in here, this is not only infrastructure. I mean, if you look in the U.S. in the transportation industry, even systems projects, they use specifications, and then at some point in time called product or construction specifications. So this is not only infrastructure. This relates to basically everything that's being built in the industry. And so how can systems engineering help, right? And so first I want to define what is even the professional standard of care. And so if you look it up, there's different definitions, but basically what it means is you have a systematic exercise of reasonable level of care, diligence, and skill. And important is also to understand reasonable. You don't have to be perfect, but you have to work in good faith effort, right, in trying to do the right thing. However, if you fail to adhere to the professional standard of care, your company might be at risk and subject to liability. And so in my opinion, right, the big issues, really are common requirements management and V&V challenges. So you had requirements from the construction specifications of a certain materials used that shouldn't have, right, certain tests being performed that didn't meet the expectations. This should have been, I don't want to say easy. This was a big program, but it should have been manageable. And so what I'm saying is this could have been avoided from my perspective if a structured systems engineering project had been used. And so this presentation basically talks about the application of systems engineering principles to construction specifications in a large infrastructure project using a case study approach, and also presents the application of systems engineering as a systematic exercise of reasonable level of care. And by doing so, I hope that I can convince at least some people that the value of systems engineering really can be also seen as a liability protection and a risk mitigation strategy. And whatever systems engineering might have cost, right? People are very concerned about money all the time. I'm pretty sure it would have been less than $400 million. Anyway, moving on, right? I want to give some background and introduction to construction specifications in general, and also to the case study project. And so, obviously this is the U.S. project I'm talking about. This is very specific to the U.S. industry. Maybe North America, but I really want to give some background how those specs look like, and I can't really speak for the UK or other areas in Europe, Africa, Asia, you name it. But let's take a look. So construction specifications are basically part of the contract documents that govern the construction of building and infrastructure projects. That doesn't only include like the typical infrastructure, it's also energy, right, water projects. And they describe in detail the scope of work, the materials to be used, the installation methods, and the quality of workmanship. And they are an essential component, one of the three pieces of what's called, the industry calls it the PS&E approach, the plans, specs, and estimates. And so you can see the plans. Every industry develops a little bit of a tribal language, right? But what I really mean is the drawings. And then the specifications is basically the actual materials and components to be used, and then the cost estimates. And those specifications are governed by the Construction Specification Institute, which has been around for decades. And they actually develop what's called the CSI Mass Performance Standard. And they have 50 divisions. And as you can see on the right side, I'll just give you a brief overview of those divisions. Everything, 0 and 1 is basically for procurement and for general, revisions of procurement. For example, it talks about quality, scope of work, submittals, right? And then everything starting with 2 all the way down to 49 is really all about the technical stuff. So let's take a look. I'm going to use for this presentation only in order to keep it manageable. I'm focusing on a concrete specification. So this one here is a Division 3 concrete. And if you take a look, this breaks down into so-called sections, which can be confusing because the section for me is normally something within a document, but every single one of those documents is called a section. And then within, we are focusing on the first one, the Portland cement concrete. And so this is how a typical look and feel of any construction spec looks like. So you have a general part, right? This is the one I'm highlighting here, and typically describes managerial requirements such as applicability, work to be performed, codes and standards that apply, definitions, submittals as I'm showing you here, quality management. So a lot of project management and general stuff. Then the part 2 is the product that actually talks about the actual things to be used. And depending on the type of delivery method, and I'm going to talk a little bit about later, it's supposed to be what's called performance requirements. The industry calls them performance, and not to be confused with what systems, what INCOSE understands as performance. It means results-oriented requirements without describing the solution, or prescriptive, meaning the how-tos, the detailed or even proprietary products and materials. Right? In the big dig, this would have been the section that would have identified the actual materials to be used. And I cannot imagine for a second that those specs did not specify exactly what was supposed to be done. And then the part 3 is the execution. That's really the work to be performed. And again, in the big dig, this would have been identified. This would have identified the actual inspection test to be performed. And typically, it talks all about the installation, even up to all the way to up to the cleaning of a work site and whatnot. And so I'm showing a couple of examples in here, the submittals, right? The materials, the field quality control, and then even identifying certain things to be, inspection and testing to be performed. And I'm going to refer, to this back quite a bit. So I just wanted to give you an idea how this looks like. So quickly, many of you might know, I spend most of my time on high-speed rail in California. This is actually the case study project. And so we have 3 active contracts, and the CP stands for construction package. So basically, we are building infrastructure right now. And then we also have future contracts, basically the tracking systems, the actual train sets, the train operator. And so I'm focusing for right now on civil and all the infrastructure part. But again, as I said earlier, those construction specifications also apply to systems components. So let's take a look into the first one, CP1. And I don't want to single out anyone. I'm just using it because CP1 was issued like 2 years before. It's a first contract and it's most advanced in terms of. So we quite often use that as an example. So if you take this segment over here, right, this is basically a zoom in, and then you see all the different structures that are being designed and built. And if you zoom in even more, you can see over here it says overcrossing right over here. And so this is a typical, a typical bridge that goes over the future alignment. So this would be where the train's going to run, right? And so we don't want to have any grade crossings. So basically, the high-speed trains, we either go over or under from a roadway perspective. And then what you see is we have quite a number of those, right? Can you see it says Avenue 15.5, 15, 12, 11, 12, 10, 9. So basically, we have quite a number of those roadway overheads. But those are not the only ones. So we're not, but obviously this is nothing more than almost like utility relocation. You want to get everything out of the way to build the actual train guideway. And so we have, river crossings, which we call a bridge, right? We have undercrossing. So this would be the future, basically station in Fresno. So we have roadways that go under. We have trenches, which is basically like a subway, only that it's, that it's open to the top. Then we have viaducts down here, and you can see it. Some of them are pretty large, right? This is from CP3, by the way. And so in totality, we have over 225, major structures to be built, not only in CP1, but basically from CP1 to CP4, and they're being called quality milestones. And again, tribal language, but basically, it's just have to accept this is what it's called. Moving on. So this was just nothing more than the background. So let's take a look into the challenges we face, right? So first, what I want to do is describe quickly how the industry handles construction specifications. So you can't really just jump in and say, hey, you should be doing systems engineering. If you don't understand how things are being done, you don't really have any credibility being taken serious if you want to propose changes, right? So let's take a look first. So I talked about the delivery methods. So this is really the life cycle, yeah, in the common one of many, but this is the most common one. It's called design build. And basically what happens is there's some planning effort typically by the owner or an agency. And then they typically hire some help consultants to do preliminary engineering, then they go to bid. And you could argue this is some form of like a 30% design. And then either there's going to be another contractor, the actual contractor, and they typically perform the final design and the construction. And then depending on the contract type, they actually also become responsible for the maintenance or sometimes even operations. So then it would not be called design build, but it would be called design build maintain or design build operate maintain. And so this is typically on the so-called acquirer, INCOSE language or owner side. And this is typically the supplier or the design build firm. And in the old days, all of the design was typically done by the owner, and the construction firms are basically responding to the final design. That had its challenges, and so nowadays many contracts are design build. But also what it means is the big companies are still the construction companies, right? And they then hire actually a designer quite often as a subcontractor or as a JV partner. But really the one who's calling the shots is quite often the construction firm. And so for them, obviously, they can't wait to come to the construction, right? So you will see typically a lot of pressure to saying, why are we not building something yet? Anyway, moving on, talking about the specifications. So as I just said, in the old days, right, the owners had developed their own final design, and they have their own standards. So they're called standard specifications. And they're very detailed. They're really meant for construction, but still, I mean, they have those standards. And you could argue from a systems engineering perspective, this should not even happen before you actually, in the end of a final design. How would you know what type of concrete or camera or whatever to use if you don't know what your systems design looks like? That's reality. So these are the so-called standard specs. And then during final design, what happens is the construction firm typically takes those owner standards and develops them into what's called the construction specifications. And I just want to show you down here, this is the language actually from a contract which says construction specifications shall be prepared in accordance with the format of the standard specifications, which are based on the Construction Specification Institute, Master Format 2011, right? So those are the things I was trying to give you a little advance notice on the prior slides. And then obviously, once the final design is done, this becomes an actual, it's called ready for construction submittal, right, at the end of final design. And then during construction, the actual construction happens and many inspection and tests are being performed. Sorry, one step back. And obviously what we're trying to accomplish here is that whatever is demonstrated here can actually shows that's in compliance with the requirements of the construction specifications. And then so the whole industry is not really exposed or has been exposed a lot to systems engineering. If you use words like V&V, most people wouldn't know, yeah. And so I show you why. So this is again the spec here, Portland Cement Concrete. There's a section on quality assurance and control, and it says for contractor's quality management plan, right? And then it says here, include in the plan all tests the contractor will perform to verify compliance to the specification requirements. That's typically what we know as requirements management and V&V, but in the construction world, it's quality, right? So if you say, hey, you should really do V&V, they will tell you, oh, we're doing this already, yeah. And then basically what happens is, depending on the type of project, the contractors develop managed quality management plans, among many others. And quite often, as you recall, that because it's a separation between the design firm and the construction firm, you actually have also different plans, one for design quality, one for construction quality. So this is an example over here from a construction quality plan, and in this case, listing so-called construction quality procedures. Right, and one of them is inspection testing. So I just want to show you this one. If you go into those procedures, right, this will then go into the details and talks about receiving material inspection testing, in-process inspection testing, final inspection testing. You probably recall, I mean, this looks all really good, right? You could argue if this, if all of those processes, would be adhered to, then there shouldn't be any big exercise experience. And then in here, there's specific forms to be used, right? So this goes back to the procedure, and then it says an FB. Let me just show you one of those. It's actually the D form, the concrete placement checklist. So whenever concrete is being poured, this checklist is being completed, and then the checklist itself is actually also based on the construction specifications, right? And you see it would say concrete mix design submitted and approved. And in here, right, and then this goes back to the concrete mix design is basically one of the submittals to be provided. And then the mix design itself is one of the products. So basically this submittal would provide all the details of what kind of mix design is to be used. And then in the field, somebody would say, yep, check, right, done. And on top of that, there's inspection and test plans. So this is basically one example in here. You see concrete sampling and testing, and that even says the source would be this famous Portland cement concrete spec. And in here, again, right, all of those details here come directly from the construction specifications. And then they go into further detail, what kind of test method is to be used, right, the sample size. So basically more details on what the standard specs or construction specs say. And then at the end of the day, what happens is a lot of paper is being generated. So for every single one of those structures, there's probably over 1,000 pieces of paper generated or pieces of quality of records. So for example, the subcontractor's daily report, right? Every day somebody is providing a summary. The concrete mix design we just talked about, right? This is one of the submittals. And then when the concrete truck comes along, they have a concrete ticket and they get assembled into so-called concrete truck logs. Basically, how many cubic yards and certain tests are being performed, right? And then the checklists are being completed. So you can see this was actually the checklist we just looked prior. And you can also see that this is more like in the field. Obviously, people just scribble on it, right? And then it gets collected. But what it also does, it's, as I said earlier, it's a lot of information. Yeah. And then some additional requirements what we have for high-speed rail, we actually ask for contractors to perform requirements management using requirements management tools. To the knowing ones, I don't have to tell you which one it is, but basically what you see over here is, again, this is the spec, right? And then the section over here, we talk about field quality control, the type of test to be performed, and then we have an allocation of whether it applies. CDH stands for foundations, abutments are the walls of the bridges, right? And then the deck, and then which quality record is addressing it, and even a reference to where this information can be found. Anyway, so that's a quick overview, right? But again, I can't really jump in without giving that background information. But what kind of challenges did this pose from a systems engineering perspective? So basically translating, right? So I'm using only a few selected challenges, and then only the ones in red I'm going into more detail. But first, there's a large number of contract documents and requirements. There's also, the applicability now of all of those documents. I'll show you in a second. Yeah, meaning if you have a trench, if you have a tunnel, if you have an embankment, which of those requirements apply? And quite often the contract, the owners rather err on the side of safety and give you more than is needed instead of missing something. So there's a lot of information even in there that doesn't apply. And so you really have to read at the beginning through and saying, so which one is applicable, which one is not, and then where exactly do those requirements apply? And so this is not even about the quality of a requirement, it's just a pure amount of paper. And then different implementation by each contractor. So I showed you we have CP1 to CP4. And because of that design build, a lot of responsibility is given to each of the contractors. And they have their own, they're different companies, different processes. So, we're dealing with everyone doing this slightly differently. And then we talked about this, the submittals, right? There is thousands of submittals. So we have 225 structures plus I showed you, right? And easily more than 1,000 for each. So we are dealing easily with like 250,000 pieces of documents only for construction, not even all the other submittals. And then the availability of construction phase submittals, I'll show you in a second actually. And then also, all of those quality records, it's like a huge pile, so to speak, yeah? And then how do you link, basically the last one, how do you link the requirements to the submittals? How do you know when the submittal comes in, which requirements applied, and can we actually check this off, right? What's the right material being used? What's the test being performed? And does it meet the contractual requirements? So going into the ones I showed you, so this is an example of the executed contract for construction package 1 over here, and I'm showing you only a few in terms of requirements documents. So the general provisions, it's typically a more commercial document, but sometimes it includes also technical requirements. 200 some pages, 1,300 shell statements, right? Then the scope of work, roughly 100 pages, 450 almost shell statements. The design criteria manual over 1,200 pages, almost 8,000 requirements in there. The third-party agreements, another 550 pages. You get the idea, right? If you just run the page numbers, we are probably already at like 1,500, if not 2,000 or so pages. And the number of requirements goes easily into the 5-digit number. And that doesn't even include the specs, right? So the standard specs, which, if you recall, are supposed to be converted into construction specs. Again, 2,200 shell statements. And when the dust had settled, it was more like 3,000 shell statements. And so all of these, right? And so one of the big challenges now with applicability is like, geez, how do we manage, right? And which of those thousands of requirements apply to Avenue 10 as an example? I'm using this one because it was one of the first ones that is being completed and certified. Then we talked about the submittals and the submittals log. So the interesting part is it says construction phase submittals are those submittals that are required by the construction specs, right? And do not require submittal to the authority. That's one of my biggest head scratches, I have to say, yeah? So these are the specs, right? This is, again, this one over here, general submittals. All of these, right? I mean, with the exception of the ones, you know, unless required, don't have to be provided. So the contractor keeps them, more or less, right? Accessible, but still. And so if you use, for example, the first example here, the famous concrete mix design, for example, and you go now to the submittal log, and this is only one contract, this is how it looks like. Yeah? This is a filter view just looking for concrete mix. And so if you ask me now, so which one of those were used for a specific structure, I wouldn't be able to tell you. Yeah? Can you see this is for concrete strength, this is project-wide, this is for a specific roadway. I have no idea what this means. This is a third party, basically a freight railroad. This is another roadway. So the point is, it's very difficult to even understand which of those submittals belongs to which type of structure. And then I said, oh, you remember we have tracing, right? So if I'm going in here using one of the tests being, I would say slump test over here, and you say, okay, fine. So this is Avenue 11 as an example. The allocation over here, it says this is a quality record. This is even the link, so I should be able to find it. Let me go and try, yeah? So now for every one of those structures or quality milestones, as we call them, right? You recall quality milestone. There's a so-called data pack, has the following breakdown structure. And in here, it says quality, right? So quality down here, and it says, oh, there, look at this. 8.1 construction quality records. So this is basically where this one is referencing to. But if you take a look, it says 1,256 files. And once you start digging, there's many, many subfolders. Oh, actually, this, you know, I should say this is obviously what was before, yeah? So these are the challenges that we face. And so now you see these files in there, again, over 1,000. And then you say, okay, fine, this was a record, let me take a look, right? QR stands for quality record, CC, CC, CL, no. Oh, there's a quality record. Oh, it's Con1, right, for concrete. Oh, here's one, concrete 2, that's 2. And there's actually more, yeah? But once you open them, what basically the first thing you're looking at is the contractor's daily report. And it's not the slump test. And so maybe it's in there, yeah? But the point is, at this point in time, you almost forgot already what you were trying to do. So I should also mention that we are working on the oversight, right? So we are basically making sure that the contractor is actually doing what they're supposed to do. And long story short, it was really difficult, right? So first we dealt with like a huge amount of hay, as I like to call this, gazillions of submittals. We have tons of requirements in here, right? And the traceability, it did not really give us a good picture. So long story short, this was all about 24 slides or so, just to give some background and the problem statement. So what we were trying to do here, our objectives. So first, what we're trying to do is we're trying to address the systems engineering I just talked about. And so basically, determining the governing, specifications of which specs apply and which requirements in each spec apply. Then analyze and allocate the requirements to individual milestones like the trenches, bridges, you name it, right? And then even within the elements like foundations, the columns, the deck, you name it. And then bring some structure to the quality record storage system that is suitable for the large amount of records. and then provide traceability, right? Like a, almost like a 3-step process. And then also what we wanted to do is to demonstrate the professional standard of care by basically having a systematic process. And even if something, truly, if you make honest mistakes, you can say, look, this was just, by mistake, and it was not, we didn't really, didn't want to subject us to liability, so to speak. And then also, obviously, avoiding the cautionary tale of a big scenario. So we really wanted a requirements-based approach, right? Demonstrating the correct use of the specified materials, but also making sure that all the inspection tests had been performed properly. And then obviously, once we accept all the infrastructure, this is not the end of the story. This is when the real fun begins by putting track on the structures, right? And buying trains and installing the signaling systems. So we want to make sure that the handover is going smoothly between the infrastructure and the systems contractors. And so also what we wanted to do is we didn't want to go in guns blazing and saying, hey, stop everything you're doing. We have a much better way. We wanted to be very considerate. So as I showed you, right, the construction industry, they use the plan, specs, and estimates approach. They use the CSI master format. They have a GDP, which is like $600-some billion a year, over 7 million employees. And they're so used to the construction specs, you can't just go in and say, oh, you should really use like an IEEE standard or so for requirement specs. That's not going to happen. Yeah, so you have to consider working with the construction specs over there. Then you speak the language, obviously, of your client, right? In this case, continue using the quality management language. So even though we have V&D requirements, but it's widely unknown. So basically, just consider integrating the whole quality management system, including the plans we talked about, right? The procedures, the forms, the inspection test plans, the quality records. Basically, just use what we have. Also, every time you go in, right, with a design build contract, fixed price, low bid contract, and every time you come and say, oh, do it this way, basically giving specific directions, or you're saying, do something that is different than what contract says, or possibly even more, you potentially have a claim at your hands, right? Meaning more work, more money. And so basically what we then said is in order to avoid this to the degree possible, is basically reuse as much deliverables that were already created, specifically the construction specs, all the quality documents, the submittal logs, the ITPs, inspection test plans, the milestone data packs we talked about. Basically, we didn't really reinvent anything. It was just reorganizing, yeah? And then also from a deliverable perspective, we just talked about use everything existing, right? Existing specs, the existing requirements analysis was done, breakdown structures, and I'll show you. And also, obviously, whenever you want to introduce a change, quite often you have a pushback, right? People don't like change too much. So you have to make a case of why you want to change something. And the only way is if you can show something that basically it's done better. And so obviously that also depends on whom you ask, but from again, we are looking at this from an over. I'm sorry? Was that a question or just somebody not on mute?
Yeah, it was someone not on mute. If everyone can please go on mute, please. Thank you.
So then let me go on. So basically we came up with a 4-step approach, right? This is what we had in mind. So first we started with the contract documents, just requirements management, starting up with the specs, right? And then use a breakdown structure from a contractor, and then allocate the requirements. So this is a construction package over here. And then basically do the V&V part by using folders. And then basically those quality records will be placed in here. And then last but not least, we want to establish the traceability, right, from the specs all the way to the quality document, so to speak. And so I'll go now quickly into the actual things that we did. So step number 1, requirements management. So the first thing what we did is we developed what we call a requirements management model. And so starting out with the contract documents, basically we have the contract documents, and there's many others, right? So I'm focusing only on the specs, but we're starting out with the standard specs and the other specs as provided to the contractor. The second step then is we went through and already, remember we took a look at which ones do apply, which ones don't apply. Already we were taking out complete specs. And then within those specs, we only focused on certain requirements. And at the end of the day, we're basically eliminating 80% or so of the requirements already. And then we rolled them all over into what we call a master list of technical contract requirements. So we have, for example, all the managerial requirements we didn't even care about. Yeah. And then at this point in time, the contractor would tailor those specifications to the project, becoming the construction specs. So here there are the standard specs, here there are the construction specs. And then we went the next step in saying, based on the different types, as I showed you earlier. So now we start, basically, creating smaller buckets of requirements, right? For ad grade really means the embankments, or aerial structures means like something like this. Trenches are over here. Roadway overheads are the famous Avenue 10 I showed you about. And then even going one step further, and then the bits and pieces of each structure, foundations of the base slab, which is the bottom plate of a trench over here. Parapets are the concrete elements up here, and the subgrade is basically the dirt, right? Anyway. And then even we wanted to know, so now that you remember we had types, so to speak, and then we had many applications of the type. So these would basically be the sites. So for example, you have Avenue 10 as a roadway overhead, you have the Fresno Trench as a trench structure, you have Fresno River Viaduct as a part of an aerial structure, and there were so-called guideway packages. And so once the requirements were trickled down, then we could take those and create our famous requirements verification traceability matrix, which basically contained only requirements applicable to one site, and then the contractor would have to provide references to traceability to the objective evidence demonstrating that those requirements have been satisfied. And they could do this by using the existing quality records, right, which is in the famous quality milestone data pack. And so just to give you an example of what we did, we started off with the 65 specs in the contract package 1. And then already, at the time of the construction specs, that came down to 40 specs. And then the roadway overheads were only 17 specs. And then even the foundations were only 6 specs, right? And so this is basically what this means, right? You start off with many requirements, and then it becomes only the applicable, and then even lesser applicable depending on the type, and even more depending on the system element of the type. And then how did we know that we had 6, right? So if I'm going back here, those 6, right, for foundations, well, we used, again, the contractor's own information. They had their own inspection test plan, as we talked about here, inspection test plan. They're saying these are the specs that apply. And so we were always trying to just use what was there. And if we agreed, we would just be fine with that. And then every single spec now, if you open this, so again, this is now a requirements management tool now. We only focused on the things that were close to our heart. So you probably remember we said we wanted to make sure we use the right materials and all the tests are being performed. And this is called field quality control. Again, right? You remember the industry is focused on quality instead of D&D. But it talks about, for example, strength tests in here. And obviously everything that is related to the submittal, like the concrete mix design. So as I said earlier, by focusing only on these requirements, you can see we already skipped everything from 1.1 to 1.5. We were able to shrink it down from roughly 3,000 requirements to 600, about 600. And this is the famous attribute we're using in the tool that says this is a technical contract requirement. And then for every single one of those, right, we actually created what I would call a test case. So we created one file for each of those remaining requirements. For this spec, it was about 30. And so can you see that actually the file name is basically derived from the spec itself. It says 1.6 submittal, so it would say 1.6 submittal or sub, and then it would say A, concrete mix design, A, concrete mix design. So take a look at this one, 2.1 materials, right? This one would say 3.1 field quality control. So we wanted to make this as intuitive as possible. And so now we took all the specs and created basically estimated test cases, so to speak. And they were initially empty and had to be populated by the contractor. And then the second step, the breakdown structure. So again, we used what was already there. And so this, again, is a roadway overhead. If you can see, this is actually the high-speed train tracks, right? This is over here, the embankment. This is a different, this is a roadway over here. And I'm using Avenue 7 because this one has so-called bands, yeah? But the point is, so this is now a roadway, a typical roadway, right, which is one of the 4 different types we talked about earlier. And then a roadway breaks down into the superstructure, the substructure. And so can you see the naming convention over here? And then the substructure itself breaks down into the abutments, which are the walls of a bridge, then the pile caps, those are those concrete thingies over here, the columns, the pier caps, the CDHs, which are, can you see it says CDH over here? Those are the foundations that go into the ground. And then we already established that this foundations actually had 6 specs to apply. And again, we didn't just make the step up. We used what was available, and there's a so-called RAM allocation report the contractors had prepared. So this breakdown over here is taken directly from the contractor's prior work. So for example, it says 25, which is this one, the ID over here, and then it would say substructure and CADH. So substructure, CADH. So basically, we created this list into a folder structure, so to speak. And then we used that very breakdown structure to allocate this now to the requirements. So this concrete spec now applies to, right, the substructure, right, over here, and applies to basically the foundation. And we also knew already, because this is for concrete spec, this is basically this piece over here. So we basically have all the information on the requirements management. So we know the spec, we know the requirement, we know where it applies. And then we use the same breakdown structure to create also a folder structure to store all the quality records. And again, when I say we, this is basically what the system we developed, and then we went to all the different all the 3 contractors and asked them to implement this by, in this case, we had to issue so-called directive letters. Anyway, quality down here, right? You remember this was the one with 1,250 some files. So now what we have a structure in here, which is based on the breakdown structure of a contractor. So in this case, it would say substructure, CADH, it would say the spec again in here, right? And so this folder would contain all of these files for this spec over here. And so then, the step number 3 is the actual V&V effort. So first, as I showed you earlier, we had a tremendous difficulty to even find quality records. So the first step in the V&V process to even locate the quality records. So remember the submittals, we said, hey, we had like 20 or so submittals of our concrete mix design, and then which one was it? So now what we can do is we basically know this is a breakdown structure, right? The actual quality record, so to speak, system. And so if you go under substructure, right? If you go under CADH, for this example, you go to the spec, you will basically find these records. And if you now open those records, the first one will say the concrete mix design. This will show in this record. And so now you can actually say, oh, look at this, right? This is the quality record that satisfies this requirement for the substructure and for the foundation. If you want to know, the mix design that was being used for the deck, you would go to the superstructure, for example. And then that applies to all the different types. You can now say, hey, which material was being used? Well, you go to the material certification, right? For Portland cement as a record. You want to know what's the strength test being performed? Well, you go find this record, and this is actually the one down here. And you're actually able to find this. And now that you're able to find it, now you can actually start doing the actual, review, right, of the V&V effort by saying, okay, this was the offered objective evidence, and looking, comparing this against the actual requirements from the construction specs. Do we believe this meets the requirements? And then last but not least, the traceability. So we actually have 2 forms of traceability. One is directly from a requirements management tool. I showed you we had the allocations in here. And you also recall that we have like 600 or so requirements, and we have many, many different allocations. So if you want to do this manually, it's really kind of quite a pain, I have to say. Yeah. So we offer the contractors to automate this by providing certain scripts we can run. And just to show you an idea, all the information you need is already in here. So the first one is, if you hover over basically the X-zone traces, as they're called, you will see this one over here. And it's a combination of the two basically elements in here, for example, substructure and the CADHs, right? This is what it would show now. And we already know in the actual folder system, you would have a folder substructure, the folder CADH, right? Then we would know, hey, this is for concrete spec, so this would be the next folder. And we also know that this is for a section in this spec, right? 3.1, your quality control, the strength test. So if you open this file, this would be the record you find. So now you can actually click on the link, and this record would open. And so we were able to automate this and showing that it works. But also we do recognize that the industry is still not very requirements, let's say, heavy. Yeah, most people still prefer to just go and look at records. So they can do this now. They can go into the quality milestone data pack and saying, hey, I want to know about everything about the foundations, right? So you go to substructure, you go to foundations, you go to the concrete part, and this would be the reinforcement, for example, right? Like the rebar. And you go in there and saying, so what do you want to look at, right? Concrete mix design, right? Great. So you get those records again the same. And so, but now if people say, geez, I don't even know anymore what, I'm looking at this, but does it meet the requirements? Well, this is now where the naming convention comes into, and basically becomes handy, right? So you have already the section of the spec, you're in the spec. So all you got to do is basically open the actual constructor specs and go to those sections, and you can refamiliarize yourself basically with the requirements, right? Anyway, moving on. So I realized I should hurry up. So just talk about the summary here. So I talked about, why are we doing this, right? The big dig issue was really the trigger. I talked about how systems engineering can help as a professional standard of care. I talked about, get some background about the construction specs, the high-speed rail, the case study project. I talked about the industry, what they're doing, the challenges we were facing. And then I was talking about this was our envisioned approach, and then how we implemented this, right, with requirements and management analysis, and then how you were able to actually trace to the actual objective evidence. So quick achievements. So we believe that was actually very helpful. That really worked a lot because what was happening, we did this for Avenue 10 as an pilot template, and the reviewers were actually able to really, efficiently and effectively identify the quality records, which was the key challenge before, and that produced really, really good review comments showing that they were actually starting to review the objective evidence against the requirements. We also believe that we can avoid the cautionary tale of a big dig by actually, focusing on the materials and inspection and tests, right, which is included in the process. We believe that we can, with having the confidence that we checked everything, that we can have, accept all those milestones and certify, and then hand it over to the other contractors. And we also believe that we demonstrate really the professional standard of care by performing a systematic exercise of reasonable level of care, diligence, skill, and basically by doing so, demonstrating the value of systems engineering as a successful liability protection and risk mitigation strategy. So that brings me to the end. Thank you for hanging in. Right. Questions?
Actually, Oliver, I do. This is Alan here. I have a question, Alan Kwasi. So very nice presentation. My question is, when you look at your, the experience with this given project, looking at what did not work, do you believe that it was mostly a not knowing how to use system engineering as a process, or do you believe it's more quality control and quality assurance and quality control in the field, or was it more document management and document organization to be able to find the right document, or was it more not using the tool properly, or was it more processes that were not in place? Because I mean, the reason why I'm asking those questions is that I'm trying to determine whether or not system engineering was really needed to do the right thing. If quality processes, quality control standards were in place and documents were properly organized, and document can be defined properly, do we really need to have system engineering in this particular experience?
So there were so many options that I hardly remember. I would almost say it's the answer D, right? All of the above, almost. So if I mean, one of the key challenges was really to even find the quality records, right? And as I pointed out, is the industry doesn't really talk about the word, doesn't use the word systems engineering, but it's kind of doing that. You remember when it says under quality to verify, compliance with the requirements? It's kind of flying under a false flag, so to speak. But they're kind of doing somewhat systems engineering. But one of the key things I'm noticing in the industry is a lack of requirements-based reviews. Even if you find all the quality records, people still, when submittals come in, whether it's design or construction, there's a tendency to only look at the actual submittal, basically the product that was provided, without looking at the actual applicable requirements. So the whole requirements analysis process and trickling them down and having buckets of applicable requirements and then start your review against the requirements, because you will never be able to see or to review what is not presented to you, right? So it's more, sometimes people call this build design instead of design build, and that's, I would almost want to add the requirements to it. Anyway, so I'm not sure I'm answering your question, Alan, but it's I wish there would have been a better implementation of quality. I will almost say documentation control, right? To even access and find the quality records, but also be having a requirements-based review.
Okay, thank you.
Mm-hmm.
If I could add to that.
Hey, Russell, go ahead.
In my experience, system engineers are used to dissecting large, complex, multidisciplinary actions into small, digestible parts. So perhaps the value of system engineering is not only the organization to ensure these things are put together, or taken apart, but then also you can figure out where things go. It's translation as well. When dealing with, you're dealing with cement, your materials, but then you also have electrical people, or like the HVAC for the systems. These people may speak different languages. How do you coordinate activities and come up with a common vernacular and methodology for the approach? And I think that's where system engineers are used to being multidisciplined and, in effect, translators across many domains. And I think it's more the skill set more than what you decide to call it. I think historically, we often refer to these people as just good engineers because they knew what to do. And I believe system engineering is trying to formalize those individual skills and kind of make a discipline amongst those itself. Hopefully that helps.
I don't know if is that a question for you, Oliver, or?
Yeah,
no, it wasn't a question.
Statement, right?
Okay.
Yeah.
It was a statement to the last question. I was adding on to it from a different point of view.
Oliver, I have a question. Bruce Elliott speaking here. And by the way, thank you for your tour into what when I first came across it was a very, very foreign land, the land of construction. It's useful for systems engineers just to know how different things are. But my question concerns BIM, Building Information Management, which I don't claim to fully understand, but insofar as I understand it, it's trying to tackle a very similar problem, trying to organize the information concerned with construction projects in a way so that you can find things and line them up. Is that your understanding? And could you say anything about the relationship between the approach you've just described and BIM?
Yeah, so the way I see, BIM, right? And I mean, full disclosure, I'm not an expert, but I have, let's say, been involved enough that I probably have half dangerous knowledge about it. It's like the modeling of systems modeling. But basically, what happens is most industries or the owners are very functionally organized, right? You have mechanical groups, and you have the structural and the civil, and they all develop their own individual designs. And then when you overlay them, you run into lots of conflicts, right? And BIM is trying to avoid that by actually doing an integrated design in a model. And they even call it, basically clashing, right? They try to understand this. If you build, let's say, a high rise, and then you say, hey, in this ceiling, I'm going to put my lighting, right? And then the other guy says, no, this is where I thought my HVAC goes along, right? And the other one says, no, this is where I thought my fire, suppression system goes. So you're trying to basically do as much as you can in an integrated fashion, design so that you can avoid those clashing or conflicts, early on, right? And then you can almost print, if you still want to go with paper or PDFs, you can print your individual designs or contract designs. You can split it up and saying, but so this is not necessarily, I would say, requirements focused or V&V focused. It's trying to come up with an integrated design as early as possible. And then obviously with all the, the renderings and the simulations and 3Ds and whatnot. Yeah.
Okay, thank you.
Yeah,
that's not what I understood, but then I'm certainly not an expert. Just reminds me I need to find out more.
I think we've got a question from Patrick. Try to boil it down, but sort of, do you already have thoughts on how you might adjust your approach in transitioning on this project when it'll eventually go to from physical structures and civil engineering into software and train control and signaling integration. So that I think he was just asking, sort of how do you see the next phase of systems engineering on that?
Yeah, we're actually doing this in a more rigid form even. Yeah. So we, basically, without going into much detail, we wrote a document that's called Systems Development Lifecycle Requirements only for the next track and systems contract. And basically describe the whole process, how we want to go from stakeholder system requirements to architecture, right? Basically, the whole life cycle with all the activities we expect the contractors to perform, with all the deliverables and all the coordination that needs to be done, the interface management, and then obviously all the affected, inspection, testing, commissioning, certification requirements. So, we actually try to be considerate of not being too harsh on civil contractors, but still we want to be assured that those billion-dollar contracts actually deliver the civil ones, right? That what the contract says. And so all I can say is even more stricter in the track and systems contracts or train sets, whatnot. Yeah.
Yeah, thanks. I think there's one last question here. I think we have time for from John Clark. He's asking about, at the beginning of the presentation, there was a slide listing the fines that the contractor and subs had to pay, and sort of along the lines of what went wrong, were there faults in the approach, the systems engineering approach. So I'm not sure if you have that slide handy or.
Yeah, am I still sharing the screen so we can maybe go back?
I'm not sure, but you should be able to if you re-trigger it.
Yeah, and so I provided some links, right, where you can find this information. And basically, what the companies were found guilty of is basically, construction management oversight failures by not making sure that the contractual requirements were adhered to. And there's actually, if you Google a little bit, big, and then you'll find companies. One of them is if I'm just saying this out loud, one of the companies was Bechtel. They have a very good description actually of, and if you read, don't forget what's like a $20 billion program at the end of the day in today's dollars. And what happens is one of the first things for saying there will be no single company in the world who is willing and able to do this job, right? So you have to break it down already into sections. And then those sections are going to be managed individually. And then you're going to have all different companies. And then you have subcontractors galore. And then, so basically, you have to do the whole requirements management breakdown following this process. And this was like 20, 30 years ago. And it's just the industry is even today not doing this very well. So you easily lose track. And then there's a certain, who needs requirements? I know what I'm doing attitude, right? And before you know it, things slip through and, materials are being used and nobody notices. And it's, what can I say? It's kind of almost like a management issue. But obviously the systems engineering part could help, right, in managing that.
Yeah, absolutely. Yeah, I think we've got one more question. This is a good one on the snag management and the impact on, passing or failing tests. How did you handle that, or any thoughts on that?
Yeah, so we shouldn't forget, right, that we are systems engineers and not necessarily subject matter experts for everything. So on the oversight, so every contract has actually what's called an independent checking engineer. And so they are doing the actual test, right? And so, and if what we really want them, want everybody to do and enable them to do easily is by go, if a submittal comes in, the first step is to understand what was supposed to be done, right? What are the requirements? What is the offered objective evidence? And then, go from left to right and saying, this is what, what the requirement said, this is what the test says. So I give you an example that says perform grounding and bonding testing on every abutment for every grounding plate as an example. And just for grounding plates and 2 abutments, I would want to see a test being performed. And so basically there's supposed to be a completeness test and a correctness test, but those would be done by the subject matter expert. So we are not specifically, not me, myself, or the systems engineering team, but we really, really want to enable the whole program, right, to have this information at their fingertips so that they can actually do it. Because as you all know, if things become too complicated or too bothersome, then some people might not do it.
Hi there, it's Andy Jenkins who asked the question. I'm more thinking of the actual failures. I'm over in Manchester and rolled out a similar system on Manchester Metrolink. And it was very difficult to get the construction teams away from their paper, as I think you've already described. But I managed to prototype a tool that integrated Jira and Zephyr as a test management tool. So people could run the tests, but also report any snags in Jira. And then that would then feed back into the database. I didn't have an interface to doors, but it was more of the how did you manage the failures and record those and track the progress? Yeah, right. So I would be interested. I mean, look, I'm always interested in learning something new. Yeah. So if somebody tells me this is all not good and you have a better way of doing this, by all means, I'm very interested in listening. Yeah. So what I presented basically here is these are the challenges we faced, and this is what we did, right? We'd be more than happy to adjust and improve if there was something else we could see. Did you use this tool for the snack management, or was it still paper-based? So this is what I was trying to say, right? So we can have it both ways. So we know the traceability, we started a requirements management tool, and it traces you directly from the requirements into the quality records, but you can also review the quality records without even the requirements management tool by just having a good organization of basically substructure, superstructure, right? Deck and foundations and abutments, and then you go in and saying this is the spec on concrete or on rebar, right? And here are the things to be done, to be tested. So you can it's kind of self-explanatory, intuitive, and so you can still, get fairly far with it. And if you truly want to know, this is why we gave those test records the name of a requirement, right? So you can go back and just refresh your memory. And I can tell you after we did the pilot, and I got to see those comments by saying, oh, we looked into this, the certification, and it showed that, the certification was expired. Then you knew they found the record, and they actually looked into the record, And before that was quite challenging. So we could really see that this really resulted in quite some improvement. So I think it's a great example of system engineering gluing the overall process together in a holistic fashion, which is what I think the system engineer or the system engineering manager brings to their projects. Mm-hmm. And by the way, obviously I'm just presenting this, but we actually have some team members here. So let me just shout out Hoehne I see here. So Alan is actually working with us on the other side as a contractor. I see Chriselle here. I saw Marion earlier. So we had, Wes. So obviously this is a big team effort, right? But we truly believe we made some quite improvements and making, the management from an oversight perspective definitely easier, right? Finding things and then enabling us to do and the independent engineering firms a more effective review, right?
Well, thanks, Oliver. I guess Hoehne, we're well over time. We should probably shut down the recording. But great feedback, and I really appreciate the discussion that we've had after, and also, of course, Oliver's discussion during. So thanks, everybody, and look forward to an interesting discussion next month, as Hoehne put on the intro screen, and please stay tuned. We'll send the flyer out to everybody, and you'll have the joining information shortly. So thank you once again. Yeah, thank you for inviting me. Right, that was fun. Yeah, it's great. Thanks, Oliver. Thanks, Alan. Thank you. Thanks, everybody. Bye. Cheers.